All right, here we go. Checking audio. Audio looks good. Okay, 6 o'clock in the morning. Let's get this done, huh? Happy Monday. Okay, here we go. So we got chapter 12. Chapter 12 is a little bit heavy on the algebra. We could have gone back to geometry, but I kind of want to save some sort of geometry for the last chapter we do. So this is probably the second to last, maybe 3 more chapters, maybe 2 chapters in a project. I got to see how I want to do it. I definitely want to get a project in here. I love those. But the project has to do with geometry. So here we go. So we have parabolas. So ax squared plus bx plus c. You guys have seen this form before. You've seen it in vectoring. Okay, there's a reason why we're going to this chapter. Ax squared plus bx plus c is a standard form that you see in the trinomial for trinomial factoring that you guys have seen. Now we're actually going to work with what the graph looks like, okay, and the different components of it. Parabolas are actually pretty cool. In the equation above, the variables are x and y, and the numbers are known as a, b, and c. So a, b, and c are the constants, x and y are your variables. Pretty obvious there. The parabola looks like a U shape. Okay. 2 x-intercepts, if it crosses twice, 1 y-intercept. Okay. So it crosses twice right here. So we're going to have 1 y-intercept. If it's above or below the x-axis, there's no x-intercepts. Okay, it's going to be a lot of information pretty quick here, but you'll see as we kind of work through the problems, it kind of narrows down for you. These are really step-by-step procedures. If your notes don't look the same as this, it's okay. It's okay. I think it's the same wording or same blanks, maybe no blanks. Just pay attention. We'll be fine. Just take your own notes. If this is messy up, it looks a little bit different. I left that packet out at the school, so I don't know the exact slides that they want on the PowerPoint. But I got these notes. These notes are perfect though. Okay, how a affects the parabola. So how the first coefficient from the x squared affects the parabola. Direction, the parabola opens up or down. Okay, so it's just talking about the direction of the parabola. So if a is positive, it opens up. Okay, if it opens up, that means the vertex is the minimum value, the smallest point, the lowest point on the graph. Okay, if it's positive, it opens up. If it's negative, it opens down. Okay, and the vertex now becomes the maximum, the highest point. So think like St. Louis, the arch, the tip top of the arch. That's actually a negative parabola. Fun fact. Okay, how wide or narrow the parabola is. If a equals 1, it's normal or just standard, you could say. If a is greater than 1, it is narrow or thin, so really skinny. If a is less than 1, it's very wide. Okay, that kind of goes along with our thinking about stretches and shrinks, by the way, from transformations. How to find x-symmetry of the parabola. The x-symmetry, it's a specific formula. It's x equals negative b over 2a. So you take the constant that's on the single x, make it negative, put it over 2 times the constant on the x squared. So we'll work with that. How to find the vertex of the parabola, use the value of the x-symmetry, plug it back into the equation to find y. So once you find the x-symmetry, so that line that if you flip it over, it's symmetric, vertical usually, we can plug that back in to find the vertex. Okay, if there's no b value, the x-coordinate of the vertex is 0. All right. How to find the y-intercept, plug in 0 for x. Okay, makes sense. Because remember, x value is 0 on the y-axis. So all you gotta do is plug in 0 and it gives you it. Okay, so we're gonna do a couple of these examples. I'm gonna do 2 of these maybe, and then 1 of the graphs I left. Okay, so the first one, let's just talk about. So first thing you want to do is label your A, B, and C. Remember your A is from the x squared, B is in front of just a single x, and C is your constant with no variable on it. Okay, is it positive or negative? It's negative, right? So it opens down. Okay, so it looks like this. X is a symmetry, so we have negative b over 2a. So we just labeled our variables. So negative 4 over 2 times negative 2. So negative 4 over negative 4, x equals 1. Okay, so that is the axis of symmetry. Once you have the axis of symmetry, you plug that in to find your vertex. Plug that into this equation to find your vertex. So we plugged in 1 everywhere we saw y, and we got 1 comma 1. Y-intercept, just plug in 0 for x, cancels. We're just left with negative 1. This is pretty easy, guys. It seems like a lot at first, but it's really, it's all connected. So once you start rolling through it, it's just bang, 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 bang. Let's go down to 3x plus 12x plus 15. So if you have that in the slides, go to it. Okay, so let's just name variables. A, B, C. Remember, A is in front of the x squared, so it's going to be 3. B is 12, and C is 15. Constant. Okay, next, does it open up or down? Is this positive or negative? It's positive, right? So it opens up. Okay, X is a symmetry, so X equals negative B over 2A. All right, so B is 12, so X equals negative 12 over 2 times 3. Don't run out of room. Negative 12 over 6, x equals negative 2. Okay, so that's my axis of symmetry. Right? Do we all follow that? Negative b, negative 12 over 2 times a. A is 3, so it's just 2 times 3. So negative 12 divided by 6 is going to be negative 2. I could be wrong here. It's 6 o'clock in the morning. Okay, next thing we want to do, vertex. So let's plug in negative 2 back into the equation. For everywhere we see an x, we put in a negative 2. Okay. Okay, so we have 3 times negative 2 squared. So that's just 3 times 4. This turns into negative 24 plus 15. Okay, so 3 times 4 is 12. Negative minus 24, not 12. No. Minus 24 plus 15. Okay, 12 minus 24 is what? Negative 12. Oh, gosh. Quick math in the morning. Negative 12 plus 15 is what? 3. Okay. And once again, if you're lazy like me, I won't say lazy, but we have tools. So if you're ever doing math at 6 o'clock in the morning, really you don't need to do any mental math. You can just plug it in exactly how you see it in the calculator. Please be 3. Hey, quick math. Okay, next up. So, okay, so your vertex. Let's not skip a step here. So we got our y value for our vertex is 3. That's what we just found. That's the whole point. Okay, but our x value is, remember, negative 2. That x is a symmetry. So that's my vertex. And since it opens up, this is a minimum. All right, because it's at the bottom. Y-intercept, let's plug x in, or the 0 in for x. So this is going to cancel, that's going to cancel, and we're just going to be left with 0, comma 15. There we go. I plugged in negative 2, I got 3. I plugged in 0, I got 15. Make sure you write it as an ordered pair. Okay, I just showed you 2 of those. I think we're good on those. Let's get to graphing a little bit. So it's the same thing we're doing. It's just now we're going to put it into a graph. Okay, so in the first example, let's just walk through it. So we have x squared plus 6x plus 15. So first thing I ask you, variables. I think you should do that in any problem, whether they ask you that or not. A is going to be 1 because we don't have a number in front. B is going to be 6. C is going to be 5. Since that A is positive, it opens up. Is it standard? It is standard because this is just 1. The A is 1. What is the equation for the x-axis symmetry? So we have negative b over 2a, so b is 6, so negative 6 over 2, a is 1. X just equals negative 3. You plug negative 3 back in to get the vertex. Okay, negative 3 comma negative 4. Plug in 0 for x, you get 5. So 0 comma 5 is your y-intercept. So that'd be way up here. We don't see it on the graph. How many x-intercepts does the function have? It has 2 because it opens towards the x-axis. Right. Pretty simple there. You just label all the components. And once again, I know it seems like a lot of information, but it'll go pretty quick. Just like opening doors. Open door, step through. Open door, step through. Open door 3, step through. They're all connected. Okay, so let's do them. So identify A, B, and C. So my A is going to be negative 1. My B is going to be 6. And my C equals negative 11. Does the function open up or down? Well, it's a negative. Okay, so open it down. Is the width wide, or is the width standard, wide, or thin? It's going to be standard because A equals 1. Just negative 1, doesn't matter. What is the equation for the x-axis symmetry? So negative b over 2a. So we have 6x equals negative 6 over 2 times negative 1. So what? Negative 6 over negative 2. It's going to be 3. So my x-axis symmetry is x equals 3. So let's draw that right now. Okay, there's my AOS. X the symmetry. X equals 3. It's a good thing to label like that. Okay, what is the vertex? Let's plug 3 into the equation, see what we get. So we get negative 3 squared plus 6 times 3 minus 11. Okay, so 3 squared is going to be 9. So we have negative 9 plus 18. So it's positive 9 minus 11. Okay, once again, 6 o'clock in the morning, so I don't tell you guys wrong. So we have negative 9 plus 18 minus 11. Negative 2. Okay, so remember, that's not the answer. We want the vertex. It's a point, so it needs to be an ordered pair. So we plugged in 3. We got negative 2. This is your vertex. Right there. Okay. It opens down. We already know that, so let's just go ahead and sketch it. Now let's do y-intercept first. See if it can fit on the graph. Okay, y-intercept, remember, just plug in a 0. So we plug in a 0 here, it cancels, and we just get negative 11. Never ordered pair. It doesn't fit on the graph, so we know this opens down, so let's draw a quick sketch. Good. I don't need a T-chart right now. Just the vertex x-symmetry sketch. 3 things. Only 3 things. You can do that. Does it have a maximum or minimum value? Well, it opens down. Okay, so it's going to have a maximum because it looks like the arch. A highest point. How many x-intercepts does the function have? Well, does it open towards the x-axis? Here's the x-axis. It opens away from it, so no, it's never going to cross. If it opened up, it would. All right, we good? I think we're okay. I think we did pretty good.
for the time. Okay, that's it. All right, so that's your intro to parabolas. We'll get going more on that tomorrow. Okay. All right, see you guys.